Hi, welcome to Competitive Cracker. So in this video, we will be discussing about the canonical transformation in detail, the generating functions and how to find the missing terms and some of the applications of this canonical transformation. Let us see how can we do that. See, that transformation means it is a transformation from an old coordinate system to a new coordinate system. This transformation is done by using a generating function. When this transformation is done from an old coordinate system to a new coordinate system, there are two possibilities. The two possibilities are whether this transformation is canonical, whether this transformation is canonical or it is not canonical. It is not canonical. See, we know this transformation is canonical means the Jacobian determinant. The Jacobian determinant, the value of Jacobian determinant will be equal to 1. The value of the Jacobian determinant is equal to 1. And if it is not canonical, the value of a Jacobian determinant J will not be equal to 1. The value of a Jacobian determinant will not be equal to 1. So, I hope you know this, how to write this Jacobian determinant and what do you mean by this canonical and all these things. So, this transformation, canonical transformation and a transformation from one coordinate system to another coordinate system is very important in CSIR point of view. You will be given some transformation and you will be asked to find whether it is a canonical or not. You will be given a transformation and a generating function, and you will be given a transformation and you will be asked to find the generating function, or you will be given some generating function and you will be asked to find out the transformation, and they will play with this. So you should have a good knowledge about the canonical transformation, how to find the canonical transformation and how to calculate the different possibilities. Okay, we should have a better outlook into these kind of problems. So in this canonical transformation section, you should have a better understanding about the differentiation and integration, especially the differentiation and integration of various trigonometric functions. This is very important. Okay. So what is this canonical transformation? What is this canonical transformation? What are these canonical transformations? So transformation from one coordinate system to another coordinate system, and this is my transformation. This is my old coordinate system. See, some x coordinate and y coordinate. I have some function here, and the area defined by this function is given by the length into breadth, that is some dx into dy, some dx into dy. And I am transforming from this coordinate system to another coordinate system. See, some coordinate system r and theta. There also I am maintaining the same area. So this new area dA prime will be equal to dr d theta, dr into d theta. This is my new area. So that means we know this these two areas may not be same. So dA will not be equal to dA prime. But if you multiply this dA prime with a factor, then it will be equal. So that is a dA will be equal to some factor. I am multiplying this j into dA prime, j into dA prime, where this j is defined as a dou of x comma y by dou of r comma theta, dou of r comma theta. Where this j is defined as, if it is written in matrix form, it is defined as it is dou x by dou r into dou x by dou r, dou x by dou theta, it is a dou y by dou r and dou y by dou theta, and dou y by dou theta. So this determinant is termed as Jacobian determinant. It is called Jacobian determinant. So in our classes we have explained how to find these Jacobian determinants and so on. Okay, so this is a Jacobian determinant. So for example, if you see, this is the first this is my first transformation sum xy to r comma theta from a Cartesian coordinate system to plane polar coordinate system xy to r theta. So the area in this Cartesian coordinate system is obviously dx and dy, dx into dy, and the area in this plane polar coordinate system is dr into d theta, dr into d theta. And we have found out that dA is equal to, or dA prime is equal to some j into dA, some j into dA, right, where this j is defined as a dou of x comma y by dou of r comma theta, dou of r comma theta, and j is equal to what, dou x by dou r, dou x by dou theta, dou y by dou r, and dou y by dou theta, dou y by dou theta. And we know the conversions, x is equal to, what is x? X is equal to r cos theta, and y is equal to some r sin theta, right? So just to find out this, j is equal to what, dou x by dou r is cos theta, and dou x by dou theta, what is dou x by dou theta? It is a minus r sin theta, right? And dou y by dou r is sin theta, and what is dou y by dou theta? It is r cos theta. So r cos theta. And what is the result? It is r cos square theta plus r sin square theta, and r is taken common. Cos square theta plus sin square theta will be 1, and the value is r. So that means dA prime, that means dA prime is equal to r dA, r dA, or dx dy equals, dx dy equals r dr d theta, dx dy will be equal to r dr d theta, r dr d theta. We have while studying vector calculus, we have already found out that the area element in the plane polar coordinates, it's r dr d theta. While writing this dA is equal to r dr d theta, we know it is wrong, but how can we relate these two? It is by using the value of the Jacobian, value of the Jacobian. The Jacobian is r. So that means this transformation, if you write this, this transformation is not canonical. If it is 1, if it were 1, it was canonical. It is not 1, so it is in this transformation is not canonical. Is it clear? So you can similarly, if you calculate for if you calculate this transformation, the transformation from the Cartesian coordinate system to spherical polar coordinate system r theta phi, r theta phi. Here it is not area, it will be volume. Since it is a 3-dimensional, it will be volume. So the volume here will be what, dx into dy into dz, and here we assume that it is dr d theta d phi, dr into d theta into d phi, and we dv prime, and we assume that dv prime is equal to j into dv, dv prime is equal to j into dv, and this j is equal to dou x by dou r, dou x by dou theta, dou x by dou phi, and dou y by dou r, dou y by dou theta, dou y by dou phi, and dou z by dou r, dou z by dou theta, and dou z by dou phi. And also we know x is equal to r sin theta cos phi, or sin theta cos phi, and y is equal to r cos theta, this is x is equal to r sin theta cos phi, and y is equal to r sin theta sin phi, r sin theta sin phi, and z is equal to r cos theta. Z is equal to r cos theta. And if you substitute here dou x by dou r, dou x by dou theta, dou x by dou phi, the value of a Jacobian, you will get it as what it will be, r, it will be, the value of a Jacobian will be r square sin theta. It will be r square sin theta. That is why we write dv equals r square dr sin theta d theta d phi. R square dr sin theta d theta d phi. So dv is equal to r square dr sin theta d theta d phi. Is it clear? So just substitute it and find out. So this is the r square sin theta is the value of a Jacobian that you will get. So that r square sin theta, that term makes the volumes in the Cartesian system and the plane and the spherical polar system equal. So that is the value of a Jacobian, and dv is equal to r square dr sin theta d theta d phi, that we know. Okay, so that is how the Jacobian is being determined. So if you this transformation, if you think about the transformation, the transformation can be from an old coordinate system to a new coordinate system, and also could be vice versa, from a new coordinate system back to an old coordinate system, vice versa also. So that means old coordinate system, I am defining it as a qi pi, and the new coordinate system is defined as a capital Qi capital Pi, capital Qi capital Pi. So if you this is a transformation. So if I think it like this, I am transforming it from Qi Pi to small qi small pi, small qi small pi. The Jacobian J will be equal to dou old by dou new. Dou old by dou new. You should know how to write the Jacobian. J is Jacobian J is equal to dou old by dou new. So what will be here? Dou qp by dou small q small p. So what will be the Jacobian here? J is equal to dou q by dou q, dou capital Q by dou small p. The numerator should be same, and dou capital P by dou small q, and dou capital P by dou small p. So this is how we write the Jacobian. And if you think it in the other if you think of the other condition, that is a small q small p is transformed to capital Q capital P. It is transformed to capital Q capital P. The Jacobian is determined as dou old. What is old here? QP divided by dou new. It is a dou capital Q capital P. Clear? So what is the Jacobian here? You should know. Dou Q by dou capital Q, dou Q by dou capital P. The numerator should be same along the row. Then here dou small p by dou capital Q, and dou small p by dou capital P. So this is how we are determining the Jacobian, the value of a Jacobian. Okay, is it clear? So if this J is equal to 1, if J is equal to 1, the transformation is canonical. If J is equal to 1, the transformation is canonical. If J is equal to 1, the transformation is canonical. So in that case, we have found out that dA prime is equal to J dA, right? So J is equal to 1 means dA prime is equal to dA. dA prime is equal to dA. That means area is preserved. Area is preserved. In the transformation, area is preserved or area is constant. Okay, and also the Hamilton's equations of motion. If the transformation is a canonical, another speciality is that Hamilton's equations of motion, Hamilton's equations of motion are also preserved. The Hamilton's equations of motion are also preserved. So area is preserved and Hamilton's equations of motion are also preserved. So if j is not equal to 1, the transformation is not canonical. So you will be given different questions regarding this to check whether the given transformation is canonical or not. You should be able to find out the value of the Jacobian there. Okay, so you will be given some complex functions to find whether the given Hamilton or given the transformation is canonical or not. Okay, so you should have that much practice. We are the competitive cracker. Here we have included different varieties of problems in our classes. So if you are able to purchase our classes, you can definitely have a variety of problems. You can have variety of tastes. Okay, so we have included different problems, solved problems and unsolved problems for your practice also. So definitely it will be helpful if you can join our classes. So that is regarding canonical transformation, and you will be given some transformation. Check whether the following transformation or you will be given 2 transformations and you will be given 4 options. Only 1 is canonical, only 2 is canonical, both 1 and 2 are canonical, or 1 is canonical, 2 is not canonical, right? Like that. 4 options will be given. So you have to check one by one whether the first transformation, whether the first transformation is canonical or not, second transformation is canonical or not, like that. So you have to check and then you will have to choose between the given options. So that is the only way that you can check the canonical transformation. Okay. So based on this canonical transformation, you will have to find out the form of a new Hamiltonian from the old Hamiltonian also. That is the another application of this canonical transformation. So while studying Hamilton's equations of motion or Hamiltonian dynamics, we have seen how the new Hamiltonian and old Hamiltonian are related. They are related prime minus h is equal to dou f by dou t, that we know. Obviously we will discuss that. Okay, so so you will be asked to find out the value of a new Hamiltonian from the value of old Hamiltonian and new equations of motion also. Okay, so or you will be given a Lagrangian in the old system and you will be asked to find out the equations of motion in the new system. So from that Lagrangian you will have to write the Hamiltonian, and from that Hamiltonian you will have to find out the value of a new Hamiltonian, and from that you will have to find out the value of the new equations of motion. Okay, so read the questions carefully and answer to the question. That is very, very important. So practice is very much important in doing this kind of problems. I have told you, especially you need practice regarding the integration and differentiation of various trigonometric functions. The trigonometric functions are very, very important in this condition. Okay, so let us see. See, this is a transformation from the old system to a new system. Old system to a new system. That means if it is canonical, it is done by using generating function. 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 So that means if you are transforming from an old coordinate system of a small q small p to a new coordinate system of a capital Q capital P, a new coordinate system of a capital Q capital P, see the Lagrangian of the old coordinate system, what are Lagrangian, what are the variables on which Lagrangian depends? Lagrangian depends on qi dot and t, right? qi dot and t. And the new Lagrangian also depends on capital Qi dot and t, capital Qi dot and t. And similarly, old Lagrangian is depending on Qi, Pi, and small pi and t. And this also results in new Hamiltonian, which depends on capital Qi, capital Pi and t, capital Pi and t. Okay, and we know this Hamiltonian, the Hamiltonian in the old coordinate system is found out by summation over I, Pi Qi dot minus L, or Lagrangian is given by summation over I, Pi Qi dot minus H, See, these both are Legendre transformations that you know. Legendre transformations, Lagrangian and Hamiltonian are related by Legendre transformations. So these are in the new coordinated system. The Hamilton is related as Hamiltonian is related as H is equal to summation over I, capital Pi, capital Qi dot minus L, and the Lagrangian L is equal to summation over I, capital Pi, capital Qi dot minus H, capital Qi dot minus H. That we know. Okay. So in the canonical transformation, what is the speciality? The Lagrangian in the canonical transformation, Lagrangian is invariant. The Lagrangian is invariant under the Lagrangian, that we know. The Lagrangian is invariant under the addition of the total time derivative of a function. The Lagrangian is invariant under the addition of a total time derivative of a function. Total time derivative of a function, that we know. That is a theory part that we have already discussed while studying Lagrangian dynamics. Lagrangian is invariant under the addition of a total time derivative of some function. Let us see how can we do that. See, that means Lagrangian is invariant of that addition of a total time derivative of a function. Addition means it can be subtraction also. Subtraction is a negative addition. So it's same. So Lagrangian is invariant of the total time df by dt. Addition of a total time derivative of a function. L prime is equal to L plus or minus df by dt. Okay. So that means L prime is equal to, let us see, I am choosing this, L prime is equal to L minus df by dt. L minus df by dt. So that means L prime minus L, or L minus L prime, obviously. L prime minus L is equal to minus df by dt. I am multiplying on both sides with respect to with minus. So it is L minus L prime. L minus L prime is equal to df by dt. L minus L prime is equal to df by dt. So what is this L? L is equal to summation over I, Pi Qi dot minus H, right? It is a Pi Qi dot minus H minus summation over I, L prime. It is a capital Pi capital Qi dot minus H prime is equal to what? Df by dt. It is a df by dt. So summation over I, Pi Qi dot minus H minus summation over I, capital Pi capital Qi dot plus h prime equals df by dt, or df by dt equals summation over I, df by dt equals summation over I qi dot pi, minus capital qi dot capital pi, see, summation is taken common, and it is h prime minus h plus h prime minus h, correct? Df by dt equals summation over I qi dot pi minus capital qi dot pi plus h prime minus h. Let me put this in box and name it as equation number 1. Let it be equation number 1. And see, I am taking this f, where this f is the generating function. F is the generating function. F is the generating function, or the function which generates the canonical transformation. The function which generates the canonical transformation. See, I am taking this f as a function of small qi, capital Qi, comma t, capital Qi, comma t, qi, qt, small q, capital Qt. This is, let this be my generating function. Okay, the generating function can be qi, cap, pit, ppt, qqt, anything. Okay, pqt, anything. 4 forms are there: f1, f2, f3, f4. You may have heard. So let this be my generating function. See, what is this? From this, what is df? Df is equal to dou f by dou qi into dqi plus dou f by dou capital Qi into d capital Qi plus dou f by dou t into dt, dou f by dou t into dt. And what is then df by dt? Df by dt will become dou f by dou qi into dqi by dt is nothing but qi dot, right? Plus dou f by dou capital Qi into dqi by dt is qi dot, plus dou f by dou t, plus dou f by dou t. Let this be my equation number 2. This is df by dt, and this is also df by dt. Then what is the coefficient here? This qi dot is there, and here also qi dot is there. So comparing equations 1 and 2, comparing equations 1 and 2, dou f by dou qi. What is dou f by dou qi? Dou f by dou qi is here it is qi dot, here it is qi dot. It is pi. Dou f by dou qi is pi, and dou f by dou capital Qi. Dou f by dou capital Qi. Here it is qi dot is there, so it is also qi dot. It is minus pi dot, minus pi, or you, and h prime minus h. H prime minus h is equal to dou f by dou t. H prime minus h is equal to dou f by dou t. So you can write in a refined form pi equals dou f by dou qi, and capital Pi equals minus dou f by dou capital Qi, and h prime minus h is equal to dou f by dou t. H prime minus h is equal to dou f by dou t. So these are the canonical equations of motion. These are the canonical equations of motion. These are the canonical equations of motion. So that means for f, here f is equal to f of qi t, capital Qi t. This you may have read it as f1. So it is f1. see F1 of QQT. So from this small pi equals dou F by dou small qi. Capital Pi equals, you have got minus dou F by dou capital Qi, and H prime minus H equals dou F by dou T. Dou F by dou T. Clear? So you have got F1 and the concerned equations of motion. Clear? So to make it simple, you will have F1, F2, F3, F4. And for all these, you will have these at least 2 equations. So 4 into 2, 8 equations you will have to study. And moreover, this negative sign, wherever it comes, it causes confusion. So in order to reduce that, we have a trick. So that means here see, F is equal to F of Q, Q, T. This was our function. So what is present? Small q and capital Q are present. Small q and capital Q are present. And what are absent? What are absent? Small q is present, small p is absent, and capital Q is present, capital P is absent. And we got absent dou P is equal to dou F by dou Qi. Dou F by dou Qi, and Pi is equal to dou F by dou Qi with a negative, right? That means missing term is equal to dou F by dou present. Remember, missing term equals dou F by dou present. Dou F by dou present. Missing term equals dou F by dou present. With then how to put this negative? How to put this negative? The negative is with missing is equal to dou F by dou present, with always put small q and capital P negative. Small q and capital P negative. Please study this trick. Small q and capital P negative. Okay, so missing is equal to dou F by dou present, and small q and capital P are negative. Small q and capital P are negative. Is it clear? So, if you are given any function, by using that trick, it will be very easy for you to calculate. Okay, so let us see how can we calculate. See the first function. See the first one. F1, you call it as F1. F1 is QQT. F1 is QQT. QQT. From this missing P, small p is missing, that is dou F by dou Q. Minus or plus? It's plus. And capital P equals dou F by dou present, dou Q. Capital P is negative, so it is a minus. And H prime minus H equals dou F by dou T. Dou F1 by dou T. Okay. And this is the first case. And the second, F2. What is this F2? F2 is capital Qi to capital Pi. Capital Qi is this capital Qi is exchanged with the capital Pi. So F2 will be small q capital P T. Small q capital P T. So what is missing? Small q is present. What is missing? Small p. Small p is dou F by dou small q. Dou F by small dou small q. And capital P is there. What is missing? Capital Q is missing. Capital Q means dou F by dou present. Dou F by dou P. And here also H prime minus H is equal to dou F2 by dou T. Here also these are all our F2s. Okay. The third case, F3, is small q is exchanged with a small pi. Small q is exchanged with a small pi. So this F3 becomes pi qi Pi, Qi, T. So, small p is present. What is missing? Small q is missing. Missing is equal to dou f by dou present. With a small q is there, so it is a negative. Small q is there, so it is a negative. Okay. Is it clear? Small p is P, Q, T. So, what is present? P is present. So, what is absent? Q is missing. Q is equal to dou f by dou present. Dou f by dou present. Small q and capital P are negative. So, put a negative. And see, what is this? Small q, capital Q is present. What is missing? Capital P is missing. What is capital P? Dou f by dou capital Q. Small q and capital P are negative. Put a negative. Then here also h prime minus h is equal to dou f by dou t. Dou f by dou t. Simple. And what is F4? F4 becomes capital Q is exchanged with the capital Pi. Is exchanged with the capital Pi. So F4 will be F4 will be P small p. F4 will be small p capital P T, PPT. Okay. So what is present? Small p is present. What is absent? Small q. Dou f by dou present with a negative because of a small p. Sorry, because of a small q. And what is present? Capital P. What is absent? Capital Q. What is capital Q? It is a dou f by dou present. Dou f by dou present. And here also h prime minus h is equal to dou f by dou t. So always remember missing term. Missing term is equal to dou f by dou present. Dou f by dou present with small q and capital P negative. With a small q and capital P negative. Is it clear? I hope it is very clear to you. And this is how we have to understand the generating function. And in the coming videos, we will be seeing a generating function is given. You will have to find out the canonical transformation. And then canonical transformation is given. You will have to find out the generating function. You will have to find out the new form of a Hamiltonian. Such applications, so many applications are there, and a variety of problems are also included. So we have started our net coaching here. So if you are interested, definitely you can call in these given numbers and you can inquire about these things. Okay, so I welcome you all to Competitive Cracker so that we can study and grow together. So hope we will see you with another video. Bye bye. Thank you.